Hello again. Tonight we're going to be talking about the International Observe the Moon Night 2023. That's what the InOMN stands for. They actually have a logo for it, Observe the Moon. Um, it's the International Observe the Moon Night Astronomical Observing and Lunar Appreciation event. The event is set aside for international lunar observing by interested individuals and groups that not only want to observe but learn more about and appreciate the moon, Earth's primary natural satellite, and to learn more about the historical, contemporary, and future observations and explorations of the moon. When did it start? Well, in 2009, they had the International Year of Astronomy. There was actually something that the United Nations passed to recognize the International Year of Astronomy. Well, one of the things that came out of the 2009 to 2010 transition was NASA's Lunar Reconnaissance Orbiter and the Lunar Crater Observing and Sensing Satellite Impactor, LaCrosse, arrived at Mars in 2010. So they kind of brought up, even though it was Mars, they talked about observe the moon. So this was NASA promoting the arrival at Mars, but we're also at the moon. So the event was called We're at the Moon, but they talked about LRO and LaCrosse. So now InOMN is an annual event. It's not associated with any specific lunar event, not a lunar eclipse, although one did happen recently, partial lunar, not any particular orbital position. It happens in the second half of the year. So September, October, not a fixed date. It's not intentionally aligned with anything like Fall International Astronomy Day. It's its own thing. Although it's an international event, it is now internationally coordinated in the U.S. through NASA. So what is InOMN for Southeast Florida in 2023? Well, it's today, Saturday, October 21st. The moon rose today at 2:02 p.m. Eastern Time. Sunset was at 6:47. That meant the moon was visible in the daytime. I know for some people that's always a shocker. The highest position the moon will get to won't be all that high because orbital positions. But tonight it will occur at, well, it did occur at 7:18 p.m. But the moon will be up most of the time that people will spend time awake. So the moon will set at 12:34 a.m. tomorrow morning. So Broward Astronomy and InOMN 2023. We don't have a public observatory. We are hosting these sessions on Saturday evenings. We're not hosting a public observing session for the event. Didn't want to set up all the stuff and arrange to go to like a park that doesn't want any public there and invite only people online. And so once this presentation goes public next week, this will be our historical offering for InOMN 2023 and minutiae about the moon. Public education about the moon is an aspect of the InOMN event. So this will be on YouTube and the public can watch it. So what will the moon be tonight, phase-wise? What will it look like? Well, the moon phase tonight is first quarter. People get quarter and how much of the moon is visible mixed. They think first quarter, that means only a quarter of it is visible. No, because the moon goes through waning and waxing, and that's how you get 4 phases. So it goes through 2 of them, which means dark to half to whatever in one direction and then in the other direction. So we're at first quarter, which means the moon is about half full, about 48% full. Now we're coming off of a new moon, so the brightness of the moon, the amount of the moon that's illuminated, is steadily increasing. Its magnitude will be about -12, which means easily visible, very bright, if the sky's clear. But where was it in the sky at sunset? It was in the constellation Sagittarius, which for us in South Florida means it was kind of low in the about southern sky. So it was at sunset, it was 172 degrees as the compass goes, azimuth. South due south is 180, and it was 36 degrees above the horizon. So if you think directly overhead is 90, the horizon is 0, about halfway between the two is 45, so a little lower than halfway between horizon and zenith. So the folks at NASA that do the InOMN event, they put out a lovely picture of the moon to show, well, this is actually a half illuminated moon. So this is a bit of a fabrication, unless you said, well, we took the picture in the future, like tomorrow, then you'd get 50%. But this picture is at 50%. But it shows you a couple of the more prominent mare, or just large, dark, flat areas on the moon. They were called mare because people thought they were oceans or seas. Nope. And then it's got some round, sort of purplish blue blobs that are where Apollo landed, except they're missing some. I see 11, 17, 16, 15. Where's the rest of them? Don't know. They're on the left side in the dark. So the mare. What are all the mare? This is not a quiz. This is just information. So if you wanted to know where the mare are, you can see them by their large, dark, flat areas, and they're not completely smooth because when they were created, when like something happened on the moon, impact, you get lava flowing out. The lava covered what craters were there and formed this smooth area. And then more things hit the moon. So even though the mare look smooth, they're also pocketed with craters. But you can see how we came up with interesting names for them. What is the Sea of Nectar? Are there plants up on the moon? So why would we go to the moon before we go to other places like Mars or Venus? First thing is the travel time to the moon is mere days. 2-3 days, you're there, depending upon whether the moon is at apogee or perigee. Mars and Venus take months to get there. Communication time. If we want to talk with somebody who's on the moon or in orbit about the moon, it's a small single-digit number of seconds. If you want to talk to somebody on Mars or Venus, hour plus each way. So the moon is far easier to successfully get there. There's not a lot of complications you have to take into account. Although, if you're going to head towards the South or North Pole, you need to get a few more things precise. As a recent attempt to put a rover towards the southern hemisphere of the moon found out, oh, you forgot to take into account that other factor. Going to the moon is also a great proving ground for a variety of technologies. How long can you make your spacecraft last without, leaking or going dead or, losing pressure on something? So you can test your longevity. If it's going to last, 3 days out, a couple of days of orbiting, and then 3 days back, it's pretty durable. You can verify your navigation. When you start navigating out to the far planets in the solar system, you tend to find there's a lot of things you have to take into account. That's Helen saying, won't be here tonight. All those things that I mentioned in the previous presentation, the minutiae about all the different movements. If you're just going to the moon, there's fewer of those things you have to take into account. But if you want to go out to Jupiter or, other places towards the edge of the solar system, like Pluto, all those things come into play by just enough to make it where you thought you were going to get there, but instead you had a bad day. You can also think about propulsion. Reasonable sized tanks, you can probably carry enough fuel to get you to the moon, safe for a few orbits, and then back. And if you have a separate lander that keeps its empty body and tanks on the surface of the moon, kind of like we did with the lunar excursion modules, keep that part on the moon because you don't need it anymore, and come back in the upper section. That works. Power. The moon is still close enough that we can use solar panels for powering things on the moon. Just realize there'll be 14 days of darkness, complete darkness. because the moon rotates. And if you're on the near side, you'll always have sunlight unless there's an eclipse. If you're on the far side, you'll always have darkness, except for 14 days when you'll have daylight. So, consumables. If you're not going very far, then you can probably carry enough food and water and filter for your air to get rid of the CO2. So consumables are good. And the Earth can act like your radiation defense, and the moon can act like your radiation defense. So you don't have to worry about, having big tanks of water around your crew quarters to prevent sun emission from the sun, having your crew have a foreshortened lifespan. Although, if you're an astronaut on the surface of the moon, when a big emission occurs, yeah, all bets are off. So what kind of prior explanations have we done? The links at the end will lead you down the rabbit hole of all the different names of all of the types of missions and who did them. They've been done internationally, not just the US, not just NASA, but we initially did flybys because we didn't have the navigation down. We said, if I give it enough oomph to get it away from Earth, get it out of Earth orbit, head it in the direction of the moon, and let the craft and the moon kind of catch up with each other, then we can do a flyby of the moon and catch some pictures. And then we learned more about the navigation, said, if we kind of let the moon's gravity, if we're not going quite so fast, and we let the moon's gravity pull it, then it will fall into orbit. So we had orbiters. And then we said, let's hit it with something. So then we said, now that we can aim at the moon like a target, let's create impactors. So we had some of the Pioneer craft impact the moon. Some of them were intentional. Some of them were unintentional. Like we thought it was going to land gracefully, and instead it went bloop and hit the moon. And they're still left as scars on the moon today. And then we have landers, uncrewed things that have landed on both the near and now the far side of the moon. Rovers. We had autonomous, uncrewed rovers that went around a little ways on the moon. They were the pioneering technologies that allow us to do rovers on Mars. And then we've had things like Apollo, crewed landers. And I don't mean CRUDE, I mean CREWED, in case people are listening and not seeing the presentation. And then we had the more advanced form, which is, hey, once you're on the moon, you get to drive around a bit. So we had crewed landers with rovers. And if we go back to the moon, we're thinking of, well, there's the low bar, crewed landers with rovers. So if we go back to the moon with people on board and they land, got to have a rover. So future exploration, we're going to have more orbiters, uncrewed and crewed, because we want to look for special things like the lacrosse looked for, metallic things that might be worth something under the surface of the moon. But we also sent a probe towards the southern pole of the moon looking for water inside of craters. And it found it. We've actually also looked at water inside of craters using SOFIA and infrared. So SOFIA got there first. Landers, we're now going to be landing bigger things, bigger rovers, autonomous rovers, crewed landers with rovers, and then permanent orbiting crewed stations. So a space station in orbit around the moon. It's called Gateway. What it's going to be and how sophisticated and how big and how many pieces. It went from big enough that it would take several flights to assemble it in space, kind of like the ISS, to we're just going to use a big bada boomba rocket and push one thing up there, and it'll be kind of like the Agena. If you remember Skylab and Agena, they were our first space stations in the US because they were basically retrofitted upper stages of rockets. Well, we could do the same thing with the Gateway station initially. And then permanent crewed bases on the moon. I'm still waiting to see what they're going to do with solar radiation. Because if you're on board and you land on the moon and you're going to be there for 3 months, you're going to get hit with a burst from the sun. There's just probability is 1. And what are you going to do to protect yourself from the radiation? I don't think we're ready for the lava tubes on the moon yet, but that would eventually be a good thing to think about. But we're thankful for the moon being there because the moon stabilizes the axial tilt of the Earth. So it helps us have reasonable, consistent seasons. It also stabilizes the rotational speed of the Earth. You know, if we get going too fast or get going too slow, the gravitational pull of the moon, you know, retrograde or prograde, tends to scoot us back into a consistent, not quite 24-hour day. And of course, we wouldn't have tides on the ocean if we didn't have the moon. Tides are good. They kind of bring things in and take things away. So in conclusion, the moon is the Earth's primary natural satellite. The sun angle changes 29.5 days. So the moon goes through its phases just less than a month. So that's why you think about things as lunar calendars as how many days in a month? I don't know, 29, 30, 31. When the moon phase is not new, the moon is prominent in the sky, whether day or night, from a sliver to half to full. When Earth gets in the way of sun to the moon, there is a lunar eclipse of the moon as the Earth's shadow crosses the moon. Earlier this month, we had a partial solar eclipse, and that's when the moon gets in the way of sunlight getting to the Earth, and the shadow of the moon passes over the Earth. So if we didn't have a moon, we wouldn't have tides, we wouldn't have stable seasons, nothing to look at in the sky, and no eclipses. So we've sent numerous things to the moon, and we've gone to various places on the moon, the safe spots, so to speak, the reasonably flat areas where if we have to move a little because we suddenly had a new crater that we didn't know was there, we could do that. But as we think about landing near the south pole of the moon, it is very much more rugged terrain, and you have to take that into account. And by the way, the Lunar Reconnaissance Orbiter still orbits the moon these days and still takes pictures. So recently, when the Russian lander did a splat on the moon, it was LRO that got the picture of. And it doesn't look like your typical thing hitting the moon. It's probably a lander that didn't go well. I consider these as starting of rabbit holes. And you can go from either the Wikipedia viewpoint or the NASA viewpoint, and then drill down to your heart's content. Any comments or questions?
Yeah, this might be a dumb question, but does the moon look bigger when it's closer to the Earth, or is that like an optical illusion?
It's except by astronomers who notice the difference digitally, it's not really noticeable. There is every orbit of the moon around the Earth, a perigee and an apogee, where the distance changes by thousands of miles.
Mm-hmm.
Occasionally, perigee will be unusually close by maybe another couple hundred miles, and we call that, when it occurs coincident with a full moon, that's what we call a supermoon.
Mm-hmm.
A supermoon is about 15% brighter, and I think it's about 8% larger. So unless you're paying attention, supermoon goes unnoticed.
Yeah, sometimes it looks really bigger to me when it's really big and bright coming through the trees and stuff.
Uh-huh. Well,
really
that's a matter of perspective. If you, when the moon is full and down low near the horizon, stick out your hand and take your little finger and use it to blot out the moon, the last knuckle of your little finger. And that's 1/2 a degree. That's the angular diameter of the full moon. Now, when the moon is overhead that same night, when it's full and it's overhead, take your arm, extend it upward, cover the moon with your little finger. The same angular size moon. When the moon is down low to the horizon, you have things you can compare it against. When the moon is overhead in a big open sky, you have nothing to compare it against, and it looks small. But when you have the moon near the horizon and it's right next to a 10-story building, you can go, the moon is as big as a 10-story building. From your visual perception, that is true. But it's that same size moon that when it's overhead, it looks so small. Extend your hand, measure it at the horizon, measure it overhead. It's the same size. You just don't have anything to compare it against.
So that would be a little bit of an optical illusion.
Or as I like to refer to it, an optical delusion. The moon is bigger.
Yeah.
Really? Is it? Is it? It is an optical illusion, but illusion says there's some kind of trickery going on, but it's not. It's just human perception. We compare things. So the moon near a building or trees or whatever, or a mountain, coming up over a mountain, we compare it. We know how big the building and trees and a mountain are, and if the moon, obscures the same area of sky, the moon must be huge. No, it's still pretty much a quarter the size of the Earth.
Yeah. Oh, thank you.
Okay. But those kind of things go into the public YouTube video as, something that people can, pass along to their friends.
Yeah, with the finger.
Yeah.
Give them a finger.
Yeah, they can use a different finger than usual. Because that finger would be bigger than the moon.
Yeah.
The real question is human physiology. Why is it that no matter how big your hands are, or how long your arms are, or how short your arms are, the width of the end of your little finger, that first joint, based upon the distance your arm can get from your eye, gives you that half a degree. So that means that human physiology is scalable. If you're tall, you got long arms and big hands, then your little finger, which is bigger because your hand's bigger, is going to be further away from your face and occupy less angular dimension.
Well, I think artists use like a thumb or something to hold out and get measurements when they're doing portraits.
That's for consistency, and that's for perspective. The old Renaissance painters, you would always see, they would be holding the brush and they'd flip their hand around and do this kind of thing, look at something. They were judging how big is the thing I'm currently holding my thumb in front of compared to something else. And they realized that by moving their hand back and forth, the finger size changes based upon the size of the object they're looking at, and therefore you have perspective. But if you look prior to the Renaissance, when they hadn't realized that yet, everything was flat. Everything was the same size. Perspective was not part of art. Even though it existed in nature. Now, who knows a good example of a corporation using perspective to play a trick on their customers? Walt Disney World.
What?
If you go down Main
Castle?
If you go down Main Street, USA at Walt Disney World, the sizes of the buildings are increased at distance to make the street look different than it really does. Now, why would they do that? It's to make Cinderella's castle be the size in perspective that they wanted it to be. Because if you ever walk all the way down to Cinderella's castle, it's not a huge castle. I mean, it's a couple of stories tall, but it's not like 20 stories tall. But due to the forced perspective, when you're at the entrance to Main Street, USA, it looks huge. Because the buildings, instead of, looking like they're getting smaller with perspective, because they're further away, they actually make the buildings that are further away slightly taller so that it's flat perspective. And then you have Cinderella's castle just beyond there.
Clever.
Yeah.
The way they explained it to me one time was that if you're walking out of the park, it makes it look like you have less of a distance to go
There is
to
that
get
as well.
back to you, to get back to your car. So,
Well, I mean, that's a side effect of it.
Yeah.
Another thing that forced perspective is used in is science fiction and fantasy movies. If you
Yeah.
want to make Gandalf look huge compared to his fellow travelers, you put them off in the background, you put him way in the foreground, and then you shoot the scene with a camera lens that has a very long depth of focus. He looks enormous compared to them.
I also, when I'm driving down the street and I see the icon for a bicyclist along the road,
Mm-hmm.
it's elongated, so
Yes.
that if you're looking at it at an angle, it looks normal.
Yes, so are the text signs that are on the asphalt. If you ever look at like a stop that's printed on the asphalt or a stop ahead or something, get out of your car if you can do it safely and look at the text. The text is wedge shaped
Oh yeah,
because as you're
True.
driving down the road, your brain wants to fix on the text regardless of the fact that you're moving forward. So your brain gets a snapshot of all one size text and forms an image, and therefore you don't notice it. But yeah, if you're a bicyclist, you'll notice it. If you're walking on the asphalt, you'll notice it.
yeah, it's cool.
Just human perception.
Uh-huh.
How our eyes and brains work. Oh, Helen just said as she was leaving the museum, she saw the SpaceX Starlink launch. Well, she saw the little orange thing moving across the sky.
Can you turn off the recorder?
Any questions with the recorder on before I stop the recorder? Hearing nothing, I will stop sharing and then I will stop recording.